Welcome, stargazers. Could you ever imagine it? Picture an eminent event so massive that it makes hidden regions on Earth visible even without the night sky. That is the spectacle we may be on the verge of witnessing in the Orion constellation. The star Betelgeuse is acting peculiarly, indicating an impending supernova that will illuminate our sky like never before. But when will Betelgeuse go supernova, and what will it look like? According to experts, what secrets might this magnificent event reveal? Join us as we delve deep into the details of what's happening with Betelgeuse and the impact it could have on Earth, and perhaps the entire nearby planetary system. Located around 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any ordinary star. It's a red supergiant, one of the brightest stars known to us, shining with a luminosity over 100,000 times that of our Sun. But why does this red giant matter so much to us? Betelgeuse stands out not only for its brilliance, but also for its history and significance in human culture. Named after the Arabic expression Yad al-Jawza, which means the hand of Orion, Betelgeuse has been observed and documented by ancient civilizations for thousands of years. It has served as a guide for travelers and a source of wonder for astronomers, its reddish hue distinguishing it from other stars in the Orion constellation. Can you imagine a single star overshadowing our entire solar system? To give some perspective on Betelgeuse's sheer immensity, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star achieve such colossal dimensions? At around 10 million years old, it's significantly younger than our 5-billion-year-old Sunday. However, Betelgeuse's massive size means it burns through its material much faster, predicting a shorter lifespan than other stars. Now, this cosmic behemoth, spanning a volume large enough to contain more than 1 billion of our suns, is approaching its final phase. When stars of such size reach their twilight years, they don't fade away quietly. They exit with a grand cosmic blast, a supernova. Such an event can dominate an entire galaxy, creating regions of brilliance across vast distances. The last time Earth witnessed a supernova this close was in 1604, long before modern telescopes. This event, known as the Kepler supernova, was the last to be visible to the naked eye in our Milky Way galaxy. It remained visible for over 18 months, brighter than any other star in the night sky, and even visible during the day for weeks. What secrets do these stellar remnants reveal? Ancient records from various civilizations, including Chinese and European astronomers, documented the appearance of this new star. Interestingly, remnants of this explosion, now an expanding debris cloud, can still be observed with advanced telescopes, providing insights into the violent ends of massive stars. Supernovae have been rare for observers on Earth, but imagine a stellar explosion, so intense it rivals the brightness of a full moon, creating shadows on Earth at night, and even being visible during daylight. The radiation from such an event could charge our atmosphere, affecting satellite operations and possibly the climate. Betelgeuse, with its irregular dimming patterns, suggests it could be preparing for such a spectacular display. Could we be on the edge of witnessing one of the universe's most dramatic events? Recently, astronomers made an astonishing discovery. Between October 2019 and early 2020, Betelgeuse underwent an extraordinary transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Dimming, the star's brightness, which had been stable for decades, began to decline significantly. This sudden change was so noticeable that even casual stargazers observed it when comparing Betelgeuse to other stars in the Orion constellation. In April 2023, cosmic observations reported that Betelgeuse had returned to its usual brightness levels, leading many to believe the anomaly had ended. In a surprising twist, the following month saw Betelgeuse's brightness increase by an astonishing 50%. Such dramatic fluctuations, while typical of variable stars, were surprising for Betelgeuse, which had generally shown predictable luminosity cycles. This sudden surge reignited discussions about its future. But what caused this unexpected change? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly behaves so unpredictably. Stars are not just glowing points of light. They are dynamic entities with life cycles, behaviors, and mysteries. Some stars exhibit periodic brightness variations, much like the rhythm of Earth seasons. Throughout its stellar lifetime, Betelgeuse maintained a relatively consistent 400-day brightness cycle. However, the great dimming seemed to defy this established behavior, challenging our understanding of cosmic phenomena. So, are we on the brink of a cosmic revelation? While the exact reasons behind Betelgeuse's irregularities are still under investigation, a compelling hypothesis has emerged. This theory focuses on stellar activity and mass ejection. Imagine Betelgeuse as a colossal celestial volcano, quietly expelling massive amounts of material into space. Recent observations from the Hubble Space Telescope revealed that Betelgeuse had ejected a substantial amount of surface material into the cosmos. This event, an enormous eruption, released 400 billion times the mass typically expelled during similar solar phenomena, equivalent to several times the mass of our moon. This could explain the temporary dimming, as the expelled material formed a dense dust cloud around the star, affecting its apparent brightness. As this dust dispersed, the star's brilliance returned. Whether Betelgeuse is nearing the end of its life or simply biding its time remains a subject of debate. Researchers agree on one thing: Betelgeuse is destined to become the Milky Way's next supernova. Predicting the timing, however, remains a challenge, with estimates ranging from just a few years to 100,000 years. When we look at Betelgeuse, we're not just observing a star, we're witnessing history. The light we see today began its journey 650 years ago, during the Renaissance. The story of Betelgeuse is a reminder of the vastness and mystery of our universe, offering glimpses into cosmic processes that shape galaxies and inspire our curiosity. In this cosmic dance, time itself becomes a bridge between past and present. When we look at Betelgeuse, we're not seeing it as it is right now, but as it was centuries ago. The light we observe left the star around the mid-14th century, when the world was emerging from the Dark Ages, and events like the Black Death were reshaping human history. This delay in light travel means Betelgeuse may have already gone supernova, and we're simply waiting for the light from this event to reach us. What will a Betelgeuse supernova look like? If Betelgeuse explodes, the event will be nothing short of spectacular. For weeks, perhaps months, the supernova could be as bright as a full moon, visible even during the day. At its peak, it would likely outshine all other stars in the night sky, turning the familiar Orion constellation into a dazzling celestial show. The supernova's light would gradually fade over time, but its impact wouldn't stop there. The remnants of the explosion, a cloud of expanding debris, could create new stellar nurseries, seeding space with heavy elements necessary for forming new stars and planets. In a way, the death of Betelgeuse would give birth to new cosmic possibilities, potential impacts on Earth. While the spectacle would be stunning, what would it mean for life on Earth? Fortunately, at 650 light-years away, Betelgeuse is distant enough that its supernova wouldn't pose a direct threat. The main concern would be from radiation, but at this distance, Earth's atmosphere would protect us from harmful gamma rays. Some effects might be felt in space, particularly impacting satellites and spacecraft with increased cosmic radiation. Astronomers also speculate that Betelgeuse's supernova could influence Earth's upper atmosphere, possibly affecting climate patterns in subtle ways. Though such effects are still theoretical. A window into stellar evolution. The impending fate of Betelgeuse offers scientists a front-row seat to observe the life cycle of a massive star. Supernovae are critical to our understanding of the universe. These explosions scatter heavy elements, like iron, carbon, and oxygen, into space, which eventually become the building blocks of new stars, planets, and even life. In fact, the iron in your blood and the calcium in your bones were forged in ancient supernovae. Betelgeuse's future explosion would provide invaluable data, allowing scientists to test and refine models of stellar evolution and supernova mechanics. Modern telescopes, both ground-based and in space, are far more advanced than those available during previous nearby supernovae, so the data collected would be unprecedented. The broader cosmic connection, our fascination with Betelgeuse, isn't just about the science. It's about our connection to the cosmos. This star, a distant point of light, links us to the vast, dynamic universe beyond our planet. It reminds us of our place in the grand scheme of things, showing that the elements were made or were born in stars like Betelgeuse billions of years ago. As we continue to observe and await Betelgeuse's grand finale, it stands as a symbol of cosmic impermanence and renewal. Whether it explodes tomorrow or in 100,000 years, the story of Betelgeuse is a testament to the ever-changing, ever-evolving nature of the universe, and our ongoing quest to understand it.